Let's talk about the protocols which will be used in encryption. So there are two protocols, that is IC version 1 and IC version 2. So let's go back to our topology. So this one now. On this VPN, this is a normal VPN where if you capture a traffic, this will be in the plain text. Now, in order to encrypt this traffic, that's where you will be implementing your IC version 1 or IC version 2 protocols. So let's talk only about the IC version 1 for now. Now, what I want is that I want to encrypt the traffic between these two organizations. So this one will be my site 1, this one will be my site 2. So what I want is that I want to encrypt the traffic. So I'm using the IC version 1 now. So these are my Cisco routers over here at the end. So what I'm going to do is that IC version 2, IC version 1, what it does is like it is going to form two tunnels. So one tunnel will be forming for exchanging the parameters of encryption, which is alternatively known as a security association. Now this tunnel, the first tunnel, will make sure that both the sides have the same parameters for the to form the tunnel. So once the security association, those are the parameters, encryption parameters meets, everything is same, and they are going to authenticate themselves using some kind of key. So there are two ways you can authenticate: using the pre-shared key and using the certificate, that is the RSS signature. So let's understand with the pre-shared key. So what's happening in the phase 1? So this is the phase 1. So tunnel 1 is the phase 1, tunnel 2 is the phase 2. Now what's happening in the phase 1 is that I have configured my router saying that I want to create an encryption policy. So this policy says that my encryption values should be like 3DS. So that's you do have the encryption parameters like AES, DES, or 3DS. So you can use any one of them. So I'm using 3DS, that's the strongest one. Next, I want to hash it using the MD5 or SHA. I will use MD5. And I want to assign any group, saying that a group 2. So this group, it defines the length of the key. So the stronger the group, the higher the number of the group, the stronger the key length will be, and that much how the secure the tunnel 1 will be. Next, I want to say what type of authentication I want to do. I want to use the authentication type as a pre-shared key. So I will configure these things. Next, I will define the password, saying that my password is Cisco. So in the tunnel 1, in the phase 1, what is going to happen is that it's going to match these values, all of them, with the site 2. If everything matches, then only the tunnel 1 will be formed. So these all parameters are known as a security association, SA values. So now how the packet is now forming is I do have my public IP address, say that I'm taking an example like 172.16.1.1 and 172.16.2.1. So the source will be 172.16.1.1 and the destination will be 172.16.2.1. And inside this packet now there will be an security association will be exchanged with the data pair, all the parameters and everything. So once this phase 1 is successful, then only the tunnel 1 will be up. So once the tunnel is up, what is the use of this tunnel now? The use of this tunnel is that before they send the traffic, they will generate a session key. So this tunnel is now encrypted, no traffic will be seen. After that tunnel is formed, then they will generate a session key saying that, okay, this is my session key, for example, 1111, and it will exchange. And here also, site 1 also define one session key, maybe 2.2.2. I'm just using a random number just for example. So S2 will send a number of 1111, so use as a session key, and S1 will send to that S2 saying that 222 is my session key. So these session keys will be exchanged, then the second tunnel will be negotiated. So once the session keys are enabled, so everything they are set and they are ready to send the traffic from one side to the other side. Now that is for this phase one. Now coming to the phase two now, I want to send the traffic. That doesn't mean that there is no negotiation. To form this tunnel, again, there are some security association. That means there are some other parameters. For these parameters, I can define like a transform set. So transform set is like here we write as a policy. Here we are saying that a transform set that is like defining the characteristics of hash and encryption. So here I will say that my encryption will be 3DS. I will say that my hash will be MD5, for example. Now here, this transform set, this tunnel is known as an IPsec tunnel now. So this tunnel, which is going to send the data, that is known as a IPsec tunnel. So I'm defining those tunnel. For this tunnel, I'm defining some kind of parameters that is 3DS and MD5. Next, after that, I am defining the interesting traffic in the phase two. So I don't want all the traffic to be communicated over the tunnel, right? Because some traffic, there might be another subnet, which known as a 30 subnet, which doesn't require to communicate with this side, but have to go with the ISP and all those things. So I will define saying that the 10 network should be able to communicate with 20 network on site one. On site two, it will be reverse. 20 network should be able to communicate with the 10 network. So I will define the interesting traffic. So once the interesting traffics are defined, then we will gather these parameters under one roof that is known as a crypto map. So in this map, we are saying that who is my peer. So destination IP address. Next, what type of traffic you want to match. So I will say that match address your access list name. Next, what parameters you want to use. What is the name of this transform set? For example, I will use a T set. So I will define the T set. So once these all things are defined under the one roof that is crypto map, then the next thing is that on which interface of the router you're going to enable your tunnel. So I will say that I want to enable into the interface E0/0 crypto map. Whatever the map, for example, I will give a name as a C map. So I will say C map. That's it. Now, whenever the negotiation is taking place, so it will see on the interfaces, okay, the addresses are matching now, access list is matching. So I need to encrypt this traffic. So I have to negotiate the tunnel with the other side. So first it will try to communicate with the other side. Yes, it is able to reachable. That's fine. Once it is able to reachable, it will go to the crypto map saying that who is my peer? Yes, I'm able to reach my peer. What is the traffic? Interesting traffic. Yes, I have the interesting traffic. And what is the T set? These are the encryption types. So what it will do now on the phase two, it will send the details saying that I want to start an handshake negotiation. Can you please tell me what are your parameters? So these parameters should also match on S1. So when these two parameters matches, then only the IPsec tunnel, that is the data tunnel, will be up. And now the traffic will be sent over this tunnel. Now let's talk again back to the tunnel one now. I said that on the tunnel one, it is going to negotiate for the session keys and everything. So in this tunnel, you do have two modes. Then one is the main mode, which is considered as a secure one. Another one is the aggressive mode. Now the difference between these two modes are in the main mode, it will use 6 messages. And in the aggressive mode, it will use 3 messages. Right? So it will, on the main mode, it will use the 6 messages. And in the aggressive mode, it will use the 3 messages. Right. So in the main mode, I said that 6 messages. What are those? The first packet sent from the initiator of the IPsec tunnel to its remote endpoint. This packet contains these policies. ISACAM policy. So this policy is known as an ISACAM policy. The second packet is sent from the remote site. to the endpoint back to the initiator, this packet is the exact same information matching. So the destination, that is the, so this one will is where the traffic has been initiated here. So he will become as an initiator and he will become as a responder. All right. So now once the initiation is done, so first packet, he is sending the parameters, and the responding, his second packet, he is also sending the same parameters. Now the third packet is sent from the initiator again to the destination one, and the packet contains the key, exchange, payload, and everything, and generate the information for DH, that is the Deffelham group. I said the group number 2, so it is going to send those parameters. And the fourth packet, again, we are expecting the same thing from our destination, that is the remote side. The fifth packet is again from the initiator to the endpoint, identifying the hash and everything, making sure that the values matches, and it also it will also check the parameters and everything like password for authentication. So when the responder, that's the remote side, responds with the same values, then the what do we say, that first tunnel is up and running. So these are the 6 messages now. In the aggressive mode, you do have only 3 messages. So the first packet will be like containing enough information, like the policies and everything in the first packet. And the additional thing is that it is going to send the group. So if you remember that the group we have sent in the third packet of the mainboard, but here in the aggressive, it is directly sending in the first group. Now the second packet, the responder is going to respond with all these values and it is going to match. And the final packet is going to authenticate using the password, pre-shared key, whatever it is, and it will calculate the hash values and everything. And that's where the third packet will be sent and received. After that, the tunnel will be formed. So 6 messages in main mode, which is secure one and which is always preferred. And the 3 messages, if you want that things to speed up, it depends upon your business criticality. According to that one, you will go ahead and configure those modes. And again, when you configure the aggressive mode, that comes with the security loophole maybe in that one. So you have to understand that requirement and accordingly you have to go ahead and configure it. Now coming to the second tunnel, in the second tunnel, again, we do have 2 modes. One is the tunnel mode. Another one is the transport mode. Now, tunnel mode is the secure one, and the tunnel mode is not the secure one. Now, in the tunnel mode, what it is going to do is that whenever the traffic is being sent, so this is my packet for now. What it is going to do now is that once the traffic it is been sending, it is going to use a protocol called as the ESP protocol. So now ESP stands for Encapsulation Security Payload, and it is one of the protocols used by IPsec to provide data protection for IP packets. So ESP can provide confidentiality, data authentication, and integrity check. So this will help in the replay protection. These services are essential for ensuring that the data transmitted over the internet or other networks is not tampered with or spoofed or intercepted by the unauthorized attacker. Now coming with the transport one, it is going to check only for the confidentiality and authenticity. So it does not support the encryption, but tunnel supports the encryption. So that's where the difference is. Now, instead of ESP packet, it is going to enter some header, which is ESP header. It is going to enter the header known as an AH header. So it is just only going to provide you with the confidentiality and authenticity, or it might be the authenticity and integrity. So, but it is does not have the capability to encrypt the traffic. So that's the reason we always make sure that the mode is tunnel, because we want the traffic to be encrypted. So these are the things you have to be careful. Now, The packet has been generated, as I said, that the source and the destination, which will be used for the ISP routing. And again, you will insert an ESP header, and apart from the CSP header, you will have one more. So let me clean this up. So here now you will have another source which says that I'm coming from 10 network. There will be another destination which says that I'm going to 20 network. And again, you have your payload. And after that, you do have an ESP trailer. And now this packet will be encrypted now. Even though if there is any interception by the unauthorized attacker, he can see this whole packet, but he is not able to see the data of this particular packet payload after the ESP protocols. Everything will be encrypted. Now coming to the normal VPN, where we just create a tunnel and the traffic is being sent over it. So that will be the plain text tunnel. So whenever you do the intercept, you are exposing these all things. You're exposing the internal header, that is your internal communication IP subnets, and you're also exposing what type of data you are sending. So that's the reason we use the IKE version 1. Now, IKE version 1 can be used into site-to-site VPN. So this is the topology which we explain is normally the site-to-site or point-to-point VPN. All right, so now IKE version 2, we will discuss in a different video later on when we start the IKE version 2. But the only difference over here in the IKE version 1 and 2 are both of them are similar. But the only thing is that the IKE version 2 is flexible with encryptions parameters, that is security association. Because over here in this policy, I can say I want to do the encryption using the 3DS, and there I can also use the AES maybe, for example. On the other side, I can only configure I want to do the encryption using the 3DS. Now, when they do the, what do we say, negotiation, the Flex IKE version 2 will check, okay, I do have 3DS, I do have 3DS, it's going to match. So it's like you can, in the same policy, you are able to define multiple parameters instead of defining the one parameters. And top of that, instead of having 6 messages, it is going to have only 4 messages. And the remaining things are same. So that another name for the data tunnel is the quick mode. So this tunnel is also, this phase is also known as a quick mode. So the first phase is known as a main mode or aggressive mode. Second phase is known as a quick mode. Now the IKE version 2 gives you the capability to go ahead with the strong encryption, which currently matches with the today's requirement. And the only problem with those parameters will be that if your routers and the firewalls are very old, like a decade ago, then the IKE version 2 might not support on that one. So compatibility issue you will have. Other than that, it's much more secure than the IKE version 1. All right, so I hope this was informative for you, and thank you.